Here is the solution for day 3. Sketch the graph of this function without using the graphing calculator. As aids, look for x-intercepts and y-intercepts, symmetry, and asymptotes. Doesn't matter what you look for first. I'm going to consider asymptotes. First of all, vertical asymptotes. What are the x values that you're not allowed to use? X cannot be -2 because that would make 0 in the denominator. So there's a vertical asymptote crossing the x-axis at -2. I'm drawing that in with a dashed line. It's crossing right there at the -2 mark. Now, horizontal asymptotes. This is a rational function. There's no variable in the numerator, so the numerator is degree 0. The denominator is linear, it's degree 1. The degree of the numerator is less than the degree of the denominator. So there is a horizontal asymptote at y = 0. It traces the x-axis. I'm actually going to try to draw a dashed line along the x-axis. I don't know if it's showing up too good, but I'm tracing right on top of the x-axis. Now when I draw in the curve, any branches or whatever of the curve have got to fit along these asymptotes. Now let's look for intercepts. Are there any x-intercepts? These are called the zeros of the function. Are there any numbers that you could fill in for x and make this function turn out to be 0? Well, there aren't. We already figured out that y = 0 is an asymptote. There are no y values equal to 0, so there are no x values you could plug in and make it be 0. Now, what about the y-intercept? Will a branch cross the y-axis anyplace? To figure out the y-intercept of a function, you replace x with 0. So if you put a 0 right here, you have 1/2, which is 1/2. There is a dot at 0, a half. And so I'll put that dot on there with my red pen. That's not a lot to go on as far as locating the branches. So now we need to consider some values to get additional dots on there. For instance, what does this formula output if we use -1 for x? So -1 plus 2 makes 1. 1/1 makes 1. So -1, 1 is a dot on the graph. You know what? With that dot there and that dot there, I'm pretty sure that a branch is going to go like this, because I know it has to curve and run alongside the asymptotes. Well, that takes care of the part of the grid that is to the right of where x = -2. What's happening over here? Well, let's choose another number for x, plug it in, and see where the dot is. How about picking -3 for x? -3 plus 2 makes -1. 1/1 makes -1. So -3, -1 is a dot. You know what? Just with that one dot, I bet that the branch is going to go along the asymptote and then curve through that dot and swing down here along the other asymptote. There's what I think the graph looks like. And I found that by using asymptotes, intercepts, and also choosing a couple other numbers to plug in for x. Now let's graph that on the calculator and just check and see that we're right. So I've got the function typed in the y1. Notice the parentheses grouping the x plus 2 as the denominator. And now push graph. Here's that first curve, here's that other curve. Notice that that does match what we predicted.